for clicking on this video. Today we're going to discuss the DSP system. It's our I-Gard's ground fault relay system. We're going to discuss it by way of example. We have a example system right here. It's a isolated 208 volt system, resistively grounded. So we have our DSP system connected to it, and we're monitoring both the system for its voltages to indicate a ground fault, as well as the fault current for each feeder. So one of the things about a system is that one thing about a high resistance grounded system is that when you have a fault, that you can run continuously when a fault is present, and you see that voltage displacement. So we're gonna have a look at creating a ground fault and showing what the system looks like. So let's just go through our modules. The display module we have on front, that's connected to the power supply module, which is this one right here, and that's connected to the system module. And here are the feeder modules. The feeder modules are connected to your current sensors, which are looking at each feeder. The system module is connected to the DDR2, which is connected to the system bus voltages, to monitor the system bus voltages for the displacement that occurs on a ground fault. And the last module that we have here is the arc detection module, which is a new module that we have. So when we're looking at a system, typically we're going to be interfacing with the display module. So let's have a look at the pages that we have on the display module. So this is the DSP display module, and right now it is at its home screen. So notice that it says I-Gard, our corporation, HRG system OK. If we were an alarm, this screen would go into an alarm. It would tell you that there's an alarm occurred. So from the home screen, let's have a look at navigating. From the home screen, you can press the right button to go to the system screen. The system screen will tell you presently what the conditions are. This will tell you fault current presently on the system. There's nothing right now. Alarm level is the alarm level setting. So this means when you have a fault, if you have a fault anything beyond 50% fault, the system will go into alarm. The NGR setting is the NGR LETU setting. So this is based on the NGR LETU of the NGR on the system. In this case, we have a 1 amp NGR. Typically, for a high resistance grounding system, this will be something like 5 amps, anything under 10 or below. In this case, we have 1 amp. One page over, we're on our feeder page. So we can scroll through our feeders by using the up-down button. So we're feeder 1. IGF is how much fault current we are seeing on that feeder. This value information comes from the current sensors for that feeder. Status is okay, and it has a priority of 3. We'll go through the priorities when we talk about second fault tripping. But we can scroll through to see the second one. Second feeder is fault current level that it sees right now. Priority 2, status okay. Feeder 3, again, very little and barely any fault current on it. Priority 1, status okay. The priority numbers deal with prioritizing the feeders between each other when a second fault happens. So when a second fault happens, you have a fault on one feeder, one phase, and a fault on the other feeder for another phase. So when that happens, that creates a phase to ground to phase fault, and you have to trip one of the feeders. So you determine which feeder you trip based on the priority number. The one with the lower priority trips first before the higher priority. So in this case, feeder 3 has a priority 1. It's the lowest of them. Feeder 2 has a priority 2. This is higher. Feeder 1 has a priority 3. It's the highest for this set right now that we have. So scrolling over to the right button on from the feeder page, we go to our pulsing page. Here's where we can initiate pulsing. So when we have a fault and when we've located the feeder it is on, we can further locate the fault by employing pulsing. So what pulsing is a way of creating a signature that you can look for in looking for a ground fault. What it does is it changes the LETU current of the NGR, and it does so in a set pattern. Pulsing changes the LETU of the NGR by changing the LETU current. It cuts it in half and brings it back from 100% to 50% once a second. So what that does is it creates something to look for in finding your ground fault path. So let's have a look at how that is employed. By creating a fault, we're going to create a fault on the system by toggling this. Notice that there is a fault on feeder 1, phase A. So the home screen initially goes to this alarm. We go to our pulsing page. We go to our feeder page. We can see FLT for feeder 1, 100%. That's what the double dash means. Notice that we can see our fault current here. We're at 100% now. So if I go to turn pulsing on by going 1 over to the pulsing page, hitting the left button, that turns pulsing on. And see, notice that what we're doing is we're changing the fault current from 100% to 50% once a second. This pattern is what we're going to look for. When we place a current sensor around all 3 phases of a feeder, any feeder on the system, if we don't see that pattern, that feeder does not have the fault. But if it has the pattern, then we know that that feeder has the fault. The fault is on that feeder somewhere. So you turn pulsing on. You do that process of putting a current sensor, looking for that pattern, and you find the location of the fault, and you clear that fault. You find a way to take that equipment down and rectify the situation. So you can turn pulsing off. So that's how pulsing works. And the next page after that is the DRM page, which does resistor monitoring. So you may or may not have resistor monitoring. Here's where you monitor the health of the resistor to see if everything's okay, because you don't want a system where the resistor becomes shorted or open circuit. And then the next page is the arc detection module page. So here's where we can see our arc detection channels, and we can see if an arc flash happens. The arc detection module will initiate a trip that can be used to clear the main breaker. And that's all the pages. Again, when the DSP is a self-resetting, so when the fault is cleared, you get this screen where it says fault clear. When you're at this screen, you can hit the left button and see what the last fault was. When you hit reset, it clears that memory unless you have a logging module. If you have a logging module, then you can hit the left button and scroll through the last 100 items. So that's just some of the screen pages and what you see when you're in an alarm. The first is the home page. On the home page, it will give you HRG system okay if the system is okay. And if it's an alarm, this page will automatically turn to alarm. When you hit the right button from here, you'll go to the system page, which tells you a little bit about the system. It'll tell you how much fault current is presently on. Here it's saying that there's no fault current on the system. And it tells you what the alarm level setting is. Here it's at 50%. That's the default setting. It also tells you what the NGR let-through setting is. This is what size resistor you have on the system. Here's the 1 amp NGR. You click another button over, and you get to the feeder module page. Here you can see all your feeders, and you can see how much fault current is on each feeder, as well as their priority setting. So here we're looking at feeder 1, very little fault current if any, and it says status okay, and it tells you that its priority is priority 3. Now the priorities numbers give you a priority setting for each feeder, which is used for second fault tripping. So the priorities numbering is used for second fault tripping. The higher priority numbered feeder trip last. The lower priority numbered feeders trip first on the occurrence of a second fault. So first feeder has a priority of 3, second feeder has a priority of 2, and the third has a priority of 1. From the feeder page, if you hit the right button over, this is the pulsing page where you can initiate pulsing. You would initiate pulsing on the occurrence of a fault as a method for fault location. And the next page is the DRM page. We don't have a DRM on this lineup. And the page after that is the arc detection module page, the page for the arc detection module. So let's have a look at how the system behaves when you have a fault on. So I'm going to put a fault on the system. So this is a fault on feeder 1, phase A, and you can see that the page says fault phase A, feeder 1, and it tells you the IG fault current, ground fault current level, which is 81%. This percentage is given as a percentage of the lead-through current. So in this case, I have a 1 amp NGR, so the percentage that the DSP shows you is a percentage of that lead-through current. I can mute the beeping by pressing the down button. From this page, I can scroll over to the system page, and I can see the system showing the fault, as well as again the alarm level setting and the NGR lead-through setting. Here I can see my feeders. On feeder 3, there's nothing. Feeder 2, nothing. Feeder 1, the double dash means 100%. And it says FLT, fault. So feeder 1 is faulted. This meter, this is just a meter that deals just for this unit, shows you the fault current. Have a look, notice that the fault current is right now showing that it's at 100% for what we have. So when I go a page over to employ pulsing, I hit the left button, turn pulsing on, notice that the needle goes back and forth. So what I'm doing with pulsing is I am changing the fault current by cutting it in half once a second. That pattern is what appears in the entire ground fault circuit, ground fault path. So that pattern is what I look for. That pattern is what I look for when I'm looking for ground fault. So what I do is I turn pulsing on, and then I take a current sensor, I put it around all 3 phases of a feeder, any feeder on the system, and if I see that pattern, I know that I found a feeder that has the fault on it. So in this case, this is feeder 1. So this fault current that would be seen on feeder 1. So I can turn pulsing off, and I can remove the fault. Notice that the screen, that the DSP is self-resetting. So now the screen says fault cleared. I can hit the left button and see what the last fault was. Now let's have a look at creating a second fault and how the DSP behaves when a second fault is created. So first I'm going to create a first fault. That's my fault on feeder 1, phase A. I'm going to create a fault on feeder 2, phase C, by pressing this button. Now that creates a double fault, because when you have a fault on two different phases, that can create a phase to ground to phase fault, which draws a large amount of current. It no longer goes through the resistor, so that's why it draws a large amount of current. So that's a bad situation. So you need to clear one of the feeders. So which feeder do you clear is based on the priority number setting. So this feeder 1 has a priority of 3, feeder 2 has a priority of 2, which means that this being a lower priority, this one should trip on the creation of the second fault. So let's do it and see is it tripping. So notice that second fault, bad situation occurred, phase-to-phase fault, draws a large amount of current. We trip on this feeder 2, and feeder 1 stays in there. Notice that our first fault is still on the system. So in this sort of situation, what you do is you turn pulsing on. From this point, you would find where your fault is. Oh, it's feeder 1, and I use pulsing to further locate it, clear that fault, find out that there's, locate the fault on feeder 2. So I press reset, bring feeder 2 back on, Note that you have to reset the DSP before resetting the breaker. The trip the trip signal that is sent to the feeder remains on there as long as that feeder is tripped. So that's just a basic overview of the DSP system and how it functions, what you can expect to see in terms of looking at is finding a first fault and using it as a method, using pulsing as a method of fault location, using the screens, navigating the screens, looking at how a second fault occurs and what you see when a second fault occurs. Thank you for watching our video. Please let us know if you have any questions. We'd love to discuss further with you.